Let's get started. Today we will be solving the problem Professor and Directions, which is a simple problem from October Starters 16. So let us see the problem statement. The problem statement here says that the professor is facing north. Initially the professor is facing north and this person Tokyo, she is facing south. So the professor is facing north and Tokyo is facing the opposite of professor, that is south. This is Tokyo. Now what has to be done here? It's that we are given a string of length n, and this string of length n will contain characters either L or R. So these are the two characters that the string will contain. L would mean the direction left and R would mean the direction right. Now why are we given this string? So we are given this string because with the help of this string we have to find out that whether there is a substring of this particular string which can be used such that professor will be able to face the same direction as Tokyo. So the professor can pick up any of the random substring out of the string and use the directions that is either left or right. So initially he is facing north, and if like suppose the string is given to us as L, R, R, L. This is the string that is given to us. So now earlier the professor was facing north. Then if he follows this string, then from north he will face left. Then after left it will be right. Then again after right it will be again right turn, and again after right turn it will be left turn. And following this particular kind of string, we have to find out whether he will be able to face the south direction or not. That is the direction which Tokyo is facing. And only if in this string a substring exists such that the professor will be able to face the south direction, only then he will be able to help Tokyo. So that is the problem that we are supposed to do. Now, in order to understand that how we are going to find this out, how we are going to solve this problem, I will explain it to you in the form of a diagram. So let us see. So I have already drawn the directions here. So left of north is west and right of north is east, so that it is easier for you to understand. Now let us see the diagram. So initially we know that professor is at the north position, right? So we have written N for north. Now we will see that from north, if he turns to the left side, then he is going to go to the west direction. So he will be facing the west direction if he turns left. Now what will happen if the professor turns right? In case he turns right, then he will be facing the east direction. Now we will see that from west, if the professor turns left and the professor turns right, then which direction will they be facing? So from west, if the professor turns right, then again he will be facing the north direction. So we have gone from north to west if it was a left turn, and then from west if it is a right turn. So if you turn towards the left side and try to imagine the right turn, then it will be that you will be going to the north direction. So let's write down right here. So from west, if it is a right turn, then it will go to the north direction. Now if we talk about the left turn, what will happen if it is a left turn from the west? So if it is a left turn from west, it will go to south. So let us write down S here. This is for south, and if it is a left turn from west, then it is going to south. Now let us see from the east direction what happens. So from east, if you are turning towards left, so facing east, if you turn towards left, then you will go back to the north direction again. So what will happen? We'll put an arrow here towards the left, that is towards north. So from east, if you turn left, then you will go to north, that is the professor will go to north. Now in this case, from east, when you are turning right, then you will go to the south direction, right? Because if like you are turning left, then you're going to north. So the only thing left is south, right? So when you are turning right, then you will go to the south direction. So this diagram in itself explains that, from any particular direction, to which direction you will reach when you are turning left or right. Now, how do we find out that what do we need to do in the problem? So as you can see here that I am given the north direction, right? And in the problem it is given to us that initially the professor is facing the north direction, and whatever substring you are picking up out of the, like say suppose the string that is given to us is something like this. This is a particular string that is given to us. Now you can pick up any substring out of it, and you have to make sure that using that substring, the professor can face the south direction. So suppose that we pick up this substring that is left, right, and left. So initially what will happen? You will know that the professor was facing the north direction. Now from the north direction it is given that that he has to turn left. So from north direction if he turns left, then he will be facing the west direction. So this one we have used. After that it's given that he should face the right direction. So from west if he goes to the right direction, then he'll again be facing north. Now from north if he goes to the left direction, that is this one. From north if he goes to left, then again he'll be facing west. So it will be like a loop, and chef will not be able to, professor will not be able to face the south direction. But which substring here will work? So if we use this particular substring, that is LL, if we use this particular substring only, that is LL, then in that case you will see that professor will be able to face the south direction. So from north, left if he will turn, then he will face west. From west, so this left is being used. Now from west if he will turn to the left direction, because again L is there, right? So from west if he turn to the left direction, then he will face south. So yes, this substring will work, and from north chef will be able to turn to the south direction. Similarly, if you see that from north, if the professor turns right, so if the professor turns right from the north direction, then he will be facing east. Now from east, he has to turn to right to reach the south direction. So there is no other option. This is the only way. Like whatever substring you pick, there has to be an LL or an RR present in order for the professor to turn to the south direction. So what we have to check in this question is that whether in this particular string that is given to us, an LL or an RR is present or not. And LL and RR, what does it simply mean? That we have to check whether any two adjacent characters in this string are equal to each other or identical to each other or not. And how can we do that? Simply by running a loop, and we can check whether s of I is equal to s of I plus 1. This is a simple check that we have to make running the loop on this entire string, character by character. And if this is true anywhere, in that case we can know that the professor will be able to turn to the south direction. So I hope that you have understood this diagram. If you have a little bit of understanding about automata, then this will be very familiar to you, and it will be very easy for you to understand. But if not, then also you can simply see that by these arrows that you definitely need a left present or a right present in order for the professor to turn to the south direction from the north direction. So I hope that you have understood this, and you'll be able to write the code on your own, and you'll have understood that why we just need to check this condition, and it'll help us do this problem. So now let us see some sample test cases, but before that we will see the input, output and constraints. So the first line will be the number of test cases, and then for each test case we will be given the length of the string and the string itself in the second line. The output will be a yes if professor can save Tokyo, that is he can turn to the south direction from the north direction, else it will be a no. The constraints are the n is up to 10 to the power 5. So if we will run a loop and we will iterate through each character of the string, so it will take order of n time complexity because n is the length of the string. So I mean it will not be a problem, and we will be able to get the code accepted without time limit exceeded. So let us see some sample test cases. So here there are 12 characters in this particular string, and you can see that we have such cases in the string, such substrings in the string where two characters are identical to each other, two adjacent characters are identical to each other, that is you can see R and R here, L and L here. So definitely this one is a yes, that is professor can turn to the south direction. Now here you can see that there is just L and R individually, and no adjacent consecutive similar characters are there. So this one is a no. Again, in the last test case, you can see R and R is present. So that means it will be a yes, and professor will be able to save Tokyo. So guys, I hope that you have understood the problem. Now we'll be seeing the code in Python and in C++. So guys, this is the code in C++, and the first few lines are just the input. Now I have taken this bool f equal to false. So this is there just to determine that we have found the condition that we have two adjacent characters similar to each other. When we find this condition even once, then we can come out of the loop, because we have determined that there is at least one substring present which can help professor turn from the north direction to the south direction. That is why we are taking this bool variable. Initially it will be false. Now I have taken input for the length of the string and for the string itself. After that we will just go to the loop, and we are running the loop from 0 to less than n minus 1. Why less than n minus 1? Because we are checking characters as s of I equal s of I plus 1. So when it will reach the second last character, the second last character will be checked with the last character whether it is similar or not. Right? Now when this particular when this particular loop reaches the last character, it will not have any other character to match it with if we go to s of I plus 1. That is why we are running the loop to until the second last character only. Now we will check if s of I is equal to s of I plus 1, that is we are checking for adjacent identical characters, that is L, L or R, R, and if this condition is true, then we will make f equals to true. So this is just like a flag variable. So we'll make it true and we'll break, that is we'll come out of the loop, because we do not need to check any further. We just need this condition to be true at one place. Now after coming out of the loop, we can simply check that if f is true. So if f means that if f is true, then we will print yes. Otherwise in the else part we'll print no, which means that professor cannot save Tokyo. So that's it. This is the code in C++. Now let us submit this code and see if we are getting the correct answer or not. And also we will be doing the code in Python. So let us see that we have got the accepted answer for this. Then we will see the code in Python. Okay, so we have got the accepted answer. Now let us see the code in Python. So guys, this is the code in Python, and you can see I have not used a loop here. So this is one other method which you can use to solve this problem. So here we are, first few lines are just the input, so I'm sure that you have understood that. But here what we are doing, we are checking whether RR or LL is present in this string or not. So we can do that directly in Python using the in operator, which checks whether this particular string is present in this S or not. So it's like it's checking whether this particular substring is present in the original string or not. So here our substring would be RR or LL, that is two adjacent characters identical to each other, which in this case can only be RR or LL. So if any of this condition is true, that is this is the first condition, then we have an OR, and this is the second condition. So if any of the condition is true, if even LL or RR is present in the string, then in that case our answer would be yes, else the answer would be no. And I have already submitted this code and got the accepted answer, as you can see. So I hope that everything is clear to you, and if yes, then please do like the video. If you have any doubts, then post them in the comment section, and I'll see you in the next one.